Today we're going to be talking about solving right triangles. Now you'll remember that we've actually done a little bit of this already, but today our focus is going to be how to solve for angles in right triangles. So remember that we have actually used trig ratios to find the sides of a triangle. Now we're going to use what we call inverse trig ratios in order to find the angles within a triangle. So what are the inverse trigonometric ratios? Well, let's say you have this triangle ABC here, and angle A is an acute angle. Inverse tangent would be simply the inverse function of the tangent function. So if tangent of A is equal to some value x, then tan inverse of x is going to give you the measure of angle A. Same with sine and cosine. So if sine of A is equal to y, then sine inverse of y is equal to the measure of angle A. If cosine of angle A is equal to z, then cosine inverse of z is going to give you the measure of angle A. You can see here on the right, the ratio is written there for you, so tan inverse of BC over AC is going to give you the measure of angle A. For sine, BC over AB, inverse sine of that, would be equal to the measure of angle A, and so on. So it depends on what information you might be given, which ratio you might use, but similar to SOHCAHTOA, you would determine which sides that you have, write the ratio, and then take the inverse of that ratio to get the angle measure. All right, take a look at example 1. Use the calculator to approximate the measure of angle A to the nearest tenth of a degree. Okay, so since we're trying to find the measure of angle A, and since BC is given to us and AB is given to us, we know that BC is opposite angle A and AB is adjacent to angle A. So we want to be using the tangent ratio. So tangent of A is equal to 15 over 20 or 0.75. But we want to know what the measure of angle A is without having to guess and check tangent of a number of degree measures. So this is where inverse comes in. So you would find the inverse tangent of 0.75, and that will give you the measure of angle A. You can also opt to write tan inverse in parentheses 15 over 20 parentheses, and then that will give you the answer. Now that should give you that angle A is approximately 36.9 degrees. All right, let's look at example 2. Now let angle A and angle B be acute angles in a right triangle. Use the calculator to approximate the measures of angle A and angle B to the nearest tenth of a degree. All right, so sine of A is equal to 0.87. And so to solve for this, we would find sine inverse of 0.87, and that will give you the measure of angle A. And this said to round to the nearest tenth of a degree, so 1 decimal place, and that would be about 60.5 degrees. All right, the second one, we have cosine of B is equal to 0.15. And again, we want to use an inverse ratio if we're trying to find the measure of an angle. So the measure of angle B is going to equal cosine inverse of 0.15, which will come up to be about 81.4 degrees. All right, example 3. Suppose your school is building a raked stage. The stage will be 30 feet long from front to back, with a total rise of 2 feet. A rake, which is also an angle of elevation, of 5 degrees or less is generally preferred for the safety and comfort of the actors. Is the raked stage you are building within the range suggested? So we actually don't know what the degree measure is, but we want it to be 5 degrees or less. So we're going to have to determine whether or not building this with these measurements, with the 2 feet rise and the 30 feet length, whether or not that is going to give us a degree measure that is 5 degrees or less. So looking at the information that you have, it looks like 2 is across from the angle that we're looking for, so that would be the opposite side, and the 30 feet is the hypotenuse. So this looks like we want to use the sine ratio. So sine of x is going to equal the opposite over the hypotenuse, which would be 2 over 30. You can simplify that if you'd like, or you can leave it as 2 over 30. And now to find x, we're going to have to use the inverse ratio, so inverse sine of 0.0667 or inverse sine of 2 over 30. And that comes out to be about 3.824. So to answer the question, is the rate stage you are building within the range suggested? Yes, because we found that x is equal to 3.8 degrees or so, which is less than the 5 degrees that it can be at maximum. All right, example 4. Now say you have an entire right triangle to solve. Remember that solving a right triangle means that you are solving for all the missing sides and angles. Now, in the problems that we've done before, when you were solving, you did not need to solve for any angle measures using inverse functions. You were always given 2 of the angle measures, and so you could subtract from 180. In this example, you see here that 2 of the angle measures are missing. So we absolutely will need to use an inverse function. Now, just so you know, the angle up at the top, we're using a Greek letter theta to represent that. And for the angle on the bottom left, we're using a Greek letter beta to represent that. All right, so let's look at what we're given. We are given 2 of the sides, and so to find the third side, we can use the Pythagorean theorem. So a squared plus 6 squared is equal to 12 squared. All right, so that gives us a squared equals 108, which means that a is going to equal 6 root 3. So we've solved for one of the sides. So we actually have all the sides now. Now we just have to deal with the angle measures. So let's say you want to solve for beta. Now you have the 6 and the 12, and 6 is adjacent to beta, and 12 is the hypotenuse. So cosine of beta is equal to 6 over 12, which is equal to 1/2. But if you're solving for the angle measure, this is where you want to use the inverse cosine function. So beta is equal to inverse cosine of 6 over 12, which will give you 60 degrees. Now to find the last angle measure, because we already have 2 of the angle measures, you can subtract from 180. So that would be 180 minus the 90 minus the 60, which gives us 30 degrees. So the last angle measure there is going to be 30 degrees. So now you can solve any right triangle if you're given 2 of the sides and the right angle. You're going to be able to solve that. In the past, you were only able to solve when you were given 1 of the sides and 1 of the acute angle measures in a right triangle.